Welcome to Module 15. In this module, we'll talk about cross-site request forgery, or CSRF or XSRF attacks. A cross-site request forgery attack occurs when a user who is authenticated on a web application is tricked into unintentionally executing an action in the service. A good example of this is persuading an administrator to click a URL which deletes an account of another user. The administrator is, of course, unaware of this. How can victims execute actions without realizing it? This is what could happen if a specially crafted link is clicked and executed through an exploitation of the XSS flaw we've discussed earlier. Let's now take a look at a sample site code which illustrates this scenario. Assume as a starting point the guest book we've talked about in the module on XSS attacks. This unprotected version of the application allows users to submit any HTML code. The second part is an admin script which verifies if an authenticated user has admin privileges. If this is the case, the script enables him or her to add a user holding the login and password indicated with parameters sent through the GET method. If a user who is not logged in visits such a page, an appropriate message will be displayed. The third script enables logins to a service and utilizes the same database table for authenticating users. If the submitted data is valid, an admin session will be activated. You can see here two web browsers with unrelated sessions in progress, which indicates that there are two different users. Assume that the browser on the left side represents an administrator of an attacked service, while the browser on the right represents a hacker who's trying to gain control over the service. As you can see, the attacker is not logged in and is not in possession of a valid login or password, which means that he won't be able to perform any actions in the service. On the left is our admin. Assume he logs in using admin as the username and test as the password. As you can see, the admin has logged in successfully. Let's confirm this. The attacker is still not logged in. Let's now see what a cross-site request forgery attack looks like. You can see here a guestbook script. Let's submit to it an image, which once clicked, will execute an HTTP request to add a user to the service. Let's take a look at the script. We need to pass the action variable with an add user value. The user variable containing a username and the pass variable with a password. As you can see, an image has been included which hides a link to the admin service in its source. Now, confirm that the attacker is still not logged in and that the account has not been created. As you can see, the account does not exist in the system. Let's assume now that the administrator decides to visit the guest book. The image has not been displayed because its URL refers to a site that is not an image. The administrator could pay no attention to the fact that the image has not displayed, and won't notice that a request has been executed that adds a user to the database. Let's see the result now. A new account has been created for the attacker and he is logged into the service. Try to think of ways in which we could prevent exposing ourselves to these attacks. A good first countermeasure is securing the application against XSS flaws. However, users could still fall prey to such attacks through their websites. To secure an application from performing significant actions in the background in a potential XSRF attack, you can require re-authentication or introduce additionally generated tokens. The database could store random one-time strings, which would be added to all forms generated in a hidden field in a service. This would allow you to check server-side if a submitted token is still active. Thanks to this method, if hackers won't know the currently active tokens, their attacks will be foiled. On the other hand, using only the POST method without using GET requests cannot guarantee application security, as an attacker could use JavaScript to generate a POST request. That's all in this module. Thanks for your attention, and see you in the next part of this course, which will focus on using a browser to spy on data.